Alright. Advent of Code, day 9. Let's test the sound. Advent of Code. Alright. Sound is fine. And let's just do this. Yeah, wasn't there yesterday because too tired. So I'm doing day 9 today. Disk fragmenter. Another push of the button leaves you in the familiar hallways of some friendly amphipods. Yeah, I don't know what the fuck that is. Good thing you each somehow got your own personal mini-submarine. The historians jet away in search of the chief, mostly by driving directly into the walls. Okay, sir, sure. While the historians quickly figure out how to pilot these things, you noticed an amphipod. Okay, what is an amphipod? Okay, it's a reference to 2021. Oh, I did this. No? Oh no, it's day 23. Probably I did not. Oh no, I have some vague memory of. Huh, maybe it was something else. Yeah, I don't think I went that far on in 2021. Well, I'm getting sidetracked, but did I even do? Oh yeah, I did 2021. No, I only did like until 15 or something. How unfortunate. I did it in Rust in 2021. Did I did 2020 as well? No, okay. So it's the third year? No, fourth year. So the 21, 22, 23, and now 24. So fourth year that I'm doing Advent of Code. All right. Anyway, while the historian quickly figure out how to pilot these things, you notice an amphipod in the corner struggling with his computer. He's trying to make more contiguous free space. No one is here. Why? Because I just started and I never announce streaming. So it's like maybe you get lucky, maybe you don't. I don't know. I don't know. It's kind of a sneaky stream. You notice an amphipod in the corner struggling with his computer. He's trying to make more contiguous free space by compacting all of the files, but his program isn't working. You offer to help. He shows you the disk map, your puzzle input. He's already generated, for example, this sequence of digits. The disk map uses a dense format to represent the layout of the files and free space on the disk. The digits alternate between indicating the length of a file and the length of a free space. So a disk map like 1, 2, 3, 4, 5 would represent one block file, 2 blocks of free space, 3 blocks. Oh, okay, I see. 4 blocks of free space and then 5 blocks of file. A disk map like 909090 would represent 3 9-block files in a row with no free space between them. Each file on disk also has an ID number based on the order of the files as they appear before they are rearranged. Starting with ID 0, so the disk map 1, 2, 3, 4, 5 has 3 files, a block 1 file with ID 0, a block 3 file with ID 1, and so on and so on. Using 1 character for each block where digits are the file IDs and dot is the free space, the disk map for 1, 2, 3, 4, 5 represents these individual blocks. Okay, that makes sense. The first example above, this represents these individual blocks. Yes. I watch your streams and they are pretty good. Oh, thank you. Yeah, I don't know. I don't know if the streams are this good, but yeah, if you it's always more fun when people interact in chat and so on. Because me on my own, like coding, maybe if people arrive in the middle of it and they don't understand anything, I must assume that's not a huge amount of fun, but yeah, if you interact or ask questions about the code, it's nice. Hello, how are you doing today? Pretty good. How about you? Pretty good, pretty good. So this represents this. Why is there 8, 8? Oh, because there is a 0, then 9, 9. Okay. The M5 pod would like to move file blocks one at a time from the end of the disk to the leftmost free space block until there are no gaps remaining between file blocks. For the disk map 1, 2, 3, 4, 5, the process looks like this. Okay, I don't understand this. Ah, so he wants to move like 2 to there? No, wait. The M5 pod would like to move file blocks one at a time from the end of the disk to the leftmost free space block until there are no gaps remaining between file blocks. So we start with 2, 2 like so, and then it's like kind of a rotate right, I guess. Like, oh no, yeah, he just takes the last one and moves it there, then takes the last one, puts it in the first free space, then takes this one and put it in the first free space. Okay, I understand. The first example requires a few more steps. So first you start with the 9, put it there. So this will be 998, and then a bunch of 8 there, a bunch of 7s there. Okay, I get it. The final step of this file compacting process is to update the file system checksum to calculate the checksum, add up the result of multiplying each of these blocks' position with the file ID number it contains. The leftmost block is in position 0. I'm following your Advanced C course. Yeah, I don't know if you could call it a course. I would say more like a series of random topics on C that I think are more than beginner level. Honestly saying it is helping me a lot. Waiting to see you launch a new course on CPP2. Yeah, I will do that at some point, or at least I want to do that, but do I have time is the question. At my previous job I was doing Rust, and so I wanted to like gather some Rust experience and then do like again this same kind of series where there is no real organization, or you can just pick whichever videos you want in the series, and it's just an interesting little topic in Rust that makes you slightly more knowledgeable about it. And if you watch like 20 of those, you actually have a solid knowledge. But yeah, now that I don't do Rust anymore, unfortunately, I do C++ at work. So yeah, I guess because I did C++ before, but now that I'm gonna get some more real life experience and just find out stuff by myself, I might start doing those kinds of videos as well. But the thing is that there is already videos on like advanced C++ out there that are very well done. But I didn't saw those kinds of video in C, so that's also why I started the series, because the C content was a bit lackluster. But the C++ is actually, it's a pretty good, and the Rust content is also pretty good, so I would feel like it's kind of redundant, but yeah, maybe I find some things. So some checksum to calculate the checksum, add up the result of multiplying each of these blocks' position with the file ID number it contains. So containing, first example, 0 times 0 is equal to 0, 1 times 0. To add up, whatever. Can I just do this first? Multiplying each of these blocks' position with the ID number it contains. If a block contains free space, skip it instead. Oh, okay, I understand. So 0 times 0, 0 times 1, 9 times 2, 9 times 3, and so on and so on. Okay, I get it. And you just do the sum. Compact the M5 pod's hard drive using the process he requested. What is the resulting file system? Careful, be careful copy pasting the input for this puzzle. It is a single very long line. All right. I don't copy paste, I have a fancy script. So it's okay. Let's take the puzzle input. So this time actually the parsing will be probably way easier because there is probably just none of it. So let's put that in example, like so. Then let's do my usual content is read file example, like so. Let's just print content to make sure I have the right thing. And yes, I do. So, right, it was alternating the thing now. I guess I can just generate a pair of tuple with, or maybe not. Huh. I need to basically convert this into a list of indices where, so like this will start at indices 0, this will start at indices 3, this will start at indices 6 or 5, and so on and so on. So how do I do this? That's what I need, right? So I need to convert this to something like this. So 2 of this, 3 of this, and so on and so on. Okay. So I feel like it could be, let's keep the print and let's just do zip content and an infinite list of indices. I think that's a good start. So I will have this, except that now I need to do zip with, and this will take a lambda, which will take, let's say, a count, so n, let's say, or let's say count already, and I for index. And now I just want to do, is there a repeat? I think there is a repeat in Haskell. Haskell repeat. Repeat. Google. No, what does the repeat function do? Repeat x is an infinite. Oh, fuck. It's not. Well, it can be that. I can just do repeat repeat I, and we do take count on it. Like so. Couldn't match type char with int. Oh yeah, right. I have to say to let's what is it? X is, or can I say just disk is equal to map read int, like so, to in content. Do you think MAP should start tonight, or should I don't know anything about football, my dude. I'm probably the only Belgian that doesn't like football, so unfortunately you're talking to the wrong person. Language type applicative. Applications? Wait, applicatives. I forgot. I think it's this. To get the fancy syntax of arrobas int at int. And so I would do disk, like so. No, it's not that. What was it? What was it? Can I... Where... where the hell did I... Ah, type applications. Yes, okay, that's it. There is also replicate, right? There is? Oh, fuck, I'm stupid. Thank you. Yes. It was right below. Applications. Did I already forget the name? God damn it. No. Was it in 7? Type applications. No, it is that. Language type applications. Oops, where's my compile thing? Couldn't match type with car. Can't I do this? Thanks a lot for your videos and streams, t'es le meilleur. Merci! Merci, I'm glad you enjoyed it. But otherwise, what do you say? Replicate. Replicate. I think replicate is better. Let's do this. So I cannot map this and this. How do I do this? Whatever, can I do like C, something, this, then... Oh, I wonder why this doesn't work as well. Can't I GHCI like read, let's say 0 into int? That's not a thing, huh? Haskell 2 digit. No? Data digits. Oh, that's a package, fuck. Char to int. Is there a thing char to int? Digit to int. Oh, ord. No, it's not ord. Well, I could use ord, I guess. Digit to int. Okay, sure. So just digit to int. Up. Is it built in? No, it's not. Let's do import data character digit to int. Yes, I think that's already pretty good. So if I take the thing, well, I can't show it to you at the same time. Maybe I will just copy paste it above so that you can see as well. Like this is what we want. And I think we already have that kinda. No? Ah, yeah, except I need a toggle for the empty spaces and the non-free spaces. How do I do this? I can just if odd I then what? Then this, and it will be -1 else something. I just read takes a string and not a char as input. Yeah, I figured this out. But yeah, it's weird. I thought read was like yeah, I guess the string can only have one implementation of the read monad or whatever. No, the read class. I assume there is a class for that. But it would be weird, no? Why doesn't char implement read? Isn't read like okay, I'm getting sidetracked again, but read. So yeah, there is a class read. I'm not a crazy person. There is a class read. Why doesn't char just implement this? Read C-char. What is C-char? Oh, it's a foreign type for the C character. Okay, so there is C-char, but there is no char. Boom, 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 boom. Where was this again? Oh, C long. Yeah, there's a bunch of stuff. Is there a character somewhere? Apparently not. Oh well. I like to just create a function called parseInt assigned to read and add typing. Sometimes it's easier. Yeah, no, yeah, I wanted to do something like that, or I didn't do that exactly. I just specified the type. But somebody mentioned that you can use language type applications, and then you can do, like if you have, let's say, a list of numbers in string, like so, you can do like something like map read at int, and that's it. You can like specify the return type like this. And it's quite nice. And before that, I was doing something like whoops, like this, which is also fine, but I don't know. This syntax is quite nice. I like it. Anyway, Hello, hello, hello there, Himsvold. How are you doing today? Um, oh yeah, by the way, I saw someone did a pull request on the thing. I haven't had time to fully check it out. Maybe it's you. I don't know. But it seemed really nice. Well, maybe I can just check it out right now, since I'm not like fully into the day already. So I have a pull request here. Oh yeah, it's the use of a monad fail. I used to live in Excel actually. Oh, really? Yeah, I spent quite a few nights in Excel. It's well, it's fun at night, I guess. I like uh, the Forêt de Soigne, where I used to hike or like just chill. That's nice. This guy sent well, thanks to you, Jan Wald. Basically, I think it's what you also did this, Hymns Vault, or was it Lauren? I forget. I forgot, but like using the guard at some point in some other day to return to do an early return basically. But this guy explained that basically you don't have to use guard because the list monad implements monad fail, and so you can just literally do just the regular pattern matching, and if the pattern matching fails, it will return early for you, which is kind of epic. So yeah, that seemed quite nice. Anyhow, count. So if it's odd, I get a replication count. Oh yeah, I could do like replicate count here and then just have the rest here. So it's -1 if it's odd. Otherwise, it will be I. I div2. Something like that. I think I'm missing a parenthesis. Let's move that to the side a tiny bit. So now my -1 are like the flags, let's say. And so I have 0, 0, then a bunch of empty spots, then 1, then a solo 2, then 3, then 4. Okay, that seems good. Yeah, it's mine. I suggested the guard, then I found out maybe just handles it. Yeah, okay. Yeah, but so yeah, that was kind of cool to just know that I can just do the pattern matching and not really care. It will just return early for me. That's the kind of thing you like Haskell for. It's a shame that Haskell is like buries a lot of its knowledge. Like it feels almost like gatekeeping, like in a ton of mathematical jargon. I don't know if you can say that in English. Uh, Mathematical glossary or language. I mean, I'm sure it's not on purpose since it comes from like an academic background. But yeah, I think it's a bit of a shame. And so 888 and 29 at the end and an empty spot there. I think that's perfectly fine. And so now I need to shift them. I need to shift them somehow. How do I do this? How do I do this? If I had normal programming language, that would be extremely easy to do, but I have Haskell, so it's always a pain in the ass when you want to insert. I mean, I know there is an insert at function, but then you have to do some whoops, insert at. Is this even what I'm looking for? Maybe it's not. Maybe I'm thinking of something else. Haskell looks so ugly. Somewhere between C and APL. Strangely enough, love both of them but hate Haskell. I think Haskell looks extremely beautiful. I think, yeah. I don't know. I don't know why you find it ugly. Uh, I like it. I like the composition is really neat. I think some of the naming is a bit bad, or like out of date, or from another, not from the software engineering world. But yeah, otherwise I think it looks actually good. Like the syntax is, I don't know. I think it's quite intuitive once you know it. Yeah, I don't know. I guess it's a bit of a taste. Uh, Haskell comes with a new way of thinking about things, which is very interesting. Yeah, if you haven't learned Haskell before, or if you don't know, if you know like the basics of functional programming and then you learn Haskell, you learn like the next level of functional programming, which is really nice. Um, so what do I do with this? Can I put it in some list like uncompressed or decompressed? Decompressed. Let's say like so. Let's keep this printed. And so how do I... So I start at the end. And I need to somehow fill the empty spaces. The -1, I need to replace them by this. How can I even do this? Maybe I should start with like doing a concat on this, just so that I have one big list instead of having a bunch of sublists. And so now I start with the 9, and I put it at the first spot where there is a -1. I struggled a lot with the composition operator the first time I saw it. Now I think it's very useful sometimes. Yeah, I think, yeah, now I somewhat get it, but I don't have the full intuition for it. Like, I understand what it does, but it's like, yeah, I don't know. It's like I don't think intuitively of it or something. Or like it's a bit weird that like you go from your code to from left to right, but then as soon as you add the dot operator, you have to start thinking in the other direction, which is a bit like you have to flip between the reading styles, which is a bit tricky. How? Hmm. I wonder how to do this in like an Haskell way, because I could do like just a recursion that pretends to be a loop, and then I access my list like an array, but that will be quite, I don't know, it's not great. Mm, can I do a function that takes let's call it a fix disk, whatever, which takes a list of ints and another list of ints, which will be the same things. And so my intuition is like, this is just let's say the disk, or yeah, this will be just decompressed, and this will be like the reverse of decompressed, like remaining. And my idea is that remaining is the reverse of decompressed, so I start. Yeah, I don't know. Is there a function in Haskell to replace the first instance of a thing? Or I could create it myself. I could create it myself. Replace. Whoop, 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 whoop. Data list extra. That sounds like a package. Yeah. Is there a thing in data list by any chance? Module data list. Scan. Accumulating maps. Never looked too much into scan. What does scan does? F of z. Scan L. Scan right. Oh yeah, there is examples. Can I just look at the examples? So scan L1, let's say plus. So it takes from A to A to A. Is it kind of like fold, but it accumulates? Is it like a cumulative fold? Scan is like fold, but every result is kept in the list. Oh yeah, it is cumulative fold. Okay. Can I use that somehow? Eh. I mean, I could in a convoluted way, but let's try to stay simple. And so I would do this like R remaining, or like this would be like current, let's say. And what I would like to do is like, if we have an empty list here, then we just, well, this can be decompressed and we just return decompressed. And so this is what we return as well. Just the thing where everything is shifted. If what I have is a -1, then what do? If I reach a -1, then I just I think I can just, no, I can just do fix disk on the next. So we keep the thing we're currently like fixing, and we just go on remaining. I should just call this rest. It's shorter, and that's how I call it in every other day. So let's stay a bit consistent. Okay, so now I'm sure that current is actually an ID that I want to shift. And I just need to find the first spot in decompressed where there is -1 and replace it with current. So how do I do this? Can I Haskell list replace first instance in list? Replace an element in a list only once. I mean, I could code this myself, but yeah, they all write it themselves or use lenses. I've never did the lens thing yet. This doesn't consider that we shift the files from the last block. No, oh yeah, I forgot to mention, like, this is how I would call it. I explained this, but very briefly. So I would say decompressed and reverse decompressed. And don't forget to delete. Yeah, but oh yeah, right. Yes, indeed. Well, I guess. Huh. Well, first things first. Let's first build the thing, and then I will think about the deletion part. I think as well the reverse is not mismatched brackets. Oh yeah, right. Like so. Oh yeah, undefined. Okay. So I don't know. Can I just make my own function? I was hoping this kind of thing would be like built in, but I guess not. Where was my data? And the data sequence is somewhere. Insert at drop take. Yeah, but this is all sequence. Isn't there like an insert at for the list? Or just insert? Insert. Insert version takes. But this is like insert with sorted. First position. Yeah, okay. I guess, yeah, to delete the element at the end, I can simply do that. I just do take length. I mean, this is horrendously unoptimized, but I can just do this. So yeah, I think that would work. Although This is pretty bad, but oh well. I paired every element with its index before reversing and used the indices to delete most of the program's time was spent in my delete at implementation. And it ran in 10-15 seconds. Yeah, it's true that the program input is probably quite bigger. Let's see. How much is it? 20,000, yeah. Maybe I need to do some basic optimization. I did something similar for the first part to wait for the second part. Oh, okay, sure. So this will be fine. So whatever. Let's just do something. Replace first. First empty. Yeah, sure. It's fine. And I just do when you don't know what to name, just X and X's. And I know that there isn't an insert first, but there is a find, I think. Or oh, come on, what was it? I know there is I know there is this. I think I used it for another day. Searching by equality. There is lm lookup find. There is a find. Ah, but it doesn't say the index. Fuck. Sup. Salut. I want to find with an index, please. Or actually, wait, partition. Partition could be fine, no? Oh no, wait. No. I'm saying garbage. Pair of list element which do and do not. Yeah, no. Find index exists. It does? My savior. Oh, let's go. Finally. Okay. Thank God. Thank God for the guys that know more about Haskell than me. Find index. And let's just do like case find index of where's fuck's sake? Where's find index? I lost it. Find index takes. Well, this will just be. Why does it take? Oh, I guess yeah. Okay, I see. Find index equal x on x's, and this will return me off, and we just do something like nothing will be undefined. That's impossible, or it should be impossible. Is there a way to unwrap in Haskell? From just. Oh. From just maybe. Okay, nice. So, and it's in data maybe. Okay, so I can just do this. And I just do from just this, like so. And I have my index. Error string or from maybe. Yes. Find index, this, just outputs 2. Oh, yeah. So I have my index. And so, do I really do my? This is not fun. And do I really have to do, because I did this in another. I did this in another day as well, and it didn't feel nice, you know. So I did just do like take and then x, then drop. I decompressed, and I think it will be I plus 1 here. From maybe has a default argument. From just assume and just which you don't know. I think in this case I do, because oh yeah, maybe if I remove them. Hmm. Well, let's try it. If I have an error, I'll replace the find from just by. Yeah, it's true. At the very end, there won't be any more empty spaces, but I'm gonna trick you, and I'm gonna do like huh? Who's laughing now, huh? You like my Haskell skills? Oh wait, just talking about Haskell. Wait, from maybe has a default argument. What's the default argument? Fuck. From just. What do you mean? Yeah, that's that's about what I want. Oh well, I will see. I will see. Does this make sense? I got the index. This. And so I can do replace first empty of current into decompressed, and this will be my. And I just called fix disk on this. Oh, and I need to do this terribleness as well. I don't like this. I do not like this. You provide it a default. Oh, you're like, the from maybe. Okay. Not the from just. Yeah, okay, I understand. Do you like my little trick though? I mean, come on, it's kind of slick. Yeah, I know it's garbage. Wait, what was I doing? This. Yeah, yes, copy paste bad, but waste of time is more bad. So, like so. And the second argument will be just rest. I did it this sort too. Possibly incorrect mismatched indentation. Where? Oh yeah. I always forget the indentation rule, but basically like everything has to be after the start of the function name. Find index, not in scope. I assume data list. Find index. Or not. Couldn't match expectation. But I will turn to Grey Slick soon and more beer, even though I like your Haskell streams a lot. Jefferson Airplane. Ah, okay. I don't know what Grace Slick is, but yeah. Jefferson Airplane is very nice. Don't you need somebody to love? Yes, I do. I do, but I already have Haskell. You're not passing X's in I. Right. Thank you. Thank you. Another thing I actually don't like about Haskell, error messages, man. Like, okay, if you have an LSP, it's a bit easier, but fuck me. What is this? Just tell me I'm missing an argument. Oh, but it can't say that because of the currying. But currying is so nice. Do you want good error messages or currying? I don't know. Because you said pretty slick. Is pretty slick a Jefferson Airplane thing? Huh. So that did not work at all. It's just 0. Grace Slick. Okay, whatever. Is it the singer? Wait, that's her? Fuck me. The thing ages does to you. Okay, I mean this picture probably doesn't do her justice. That's more fine. Anyway, okay, that's the thing. Okay. Yeah, okay. The music is great. Yeah, the music is really great. I enjoy it a lot. Poo, 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 poo. So what happened to my garbage? What happened to my garbage code? Oh, wait, no. I'm a libertarian, not a hippie. But I mean, whatever. It doesn't matter your political adherence when the music is great. Uh, how I like your style. Sure. Do 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 do. What the fuck did I do? Why did I end up with a tiny list? Why? And I like. Alright. That's more hippie than libertarian, I must say. Where is the... What the fuck am I doing? Replace first empty. Okay. When in doubt, do a small test. So, print replace first empty. Let's say 10 in list. Wait, what the fuck did I do? I'm fucking stupid. Find index -1. Okay, I understand. I understand that I am stupid. Variable not in scope decompressed. Yes, because I have to put this back in where. It does not work. It does not work. What if I add more -1? Okay, that's not it. Oh well, I will do it properly. It's okay. From maybe and this will just be decompressed. I think. Oh no, this will be... Well, if I don't find an empty spot, then what? Then it will just be the length of decompressed. No, still 0. Concentrate on the Haskell, not my BS. Well, you know the Haskell isn't doing so great right now, so give me more bullshit. So this is not good. This is no good. Alright, can I retest my thing? Replace first empty. So let's just test, say 9 in a list that goes from 1 to, well, that goes like 0, 1, 2, 3, and then there is a -1, and then 6, 7, like so. Let's see what that returns. Oh yeah, right. Fuck. Well, can't this just be x's? Right? I think so. Oh, that actually just works. So it's not the problem. Yeah, that works. Okay. Oops. So what do I do now? So I know that this works. Here I'm taking the rest. And take decompressed -1. What if I don't do the take decompressed for now? Just let's just pretend that it will work without it, and start like that. And I can remove all the -1 at the end as well, I guess. Oh no, I will have to. Yeah, well, whatever. You can do find indices to get all the -1s at once. Seems more robust. Indeed. Indeed. Let's get a first proof of concept though. Let's get a first proof of concept. So, okay, that's better, except I have a bunch of stuff that didn't got replaced at the end, which is quite bad. Does that seem good? Let's check on this. So in the end, I should have something like this. Okay, so what do I have? I have 0, 0, 9, 9, 8, 1, 1, 1, and so on and so on. At some point, I have 6, 6. Yeah, a bunch of 6. So I should cut it here, basically. Okay. So, yeah. Is there a count? Is there a count? Like a count, or I could do find indices and just count this and do the length of this. Yeah, okay, I'm not using the find indices correctly, but oh well, empty space count will be the length of find indices equal -1. I wonder if I need to put the parentheses there. In decompressed, like so. Does that kind of work? No. Find indices, like so. Yes, and then I can just do this, and I can take length decompressed minus empty space count. This is the correct answer, I think. 0, 0, 9 something. Yep, that's good. I mean, it's horrendously made, but it works. So let's start with this. Like so. And now what do? I just... oh yeah, then the answer will be... I need some kind of checksum. Checksum is equal to, well, sum probably, of map. No, it will be zip with. And then I will have like ID, index, and it's just like, well, I can just do times. And it will be, so, this will be like shifted up. Let's not print this. Yeah, this is horrendous, but, and so shifted and a list from 0 to this. And then print checksum. Okay, is this the correct answer? It is! Alright, let's write on input and see it take forever. Fuck. What did I do? Oh, how do I remove the... So, like cat a input. Like it has a line feed. I don't know if you can see it, but I think my trick is not going to be a Haskell trick. It's just going to be trd remove input. Okay. And spawn input. And now there is no control N at the end. And now we wait for the next hour. So code optimization is great, you know. I'm a big fan of it. Really, I'm a big proponent of making your programs fast. Really love it. It's one of my passion. You can use find indices to get all the -1s in the filter or init. Filter or init? Hmm. Ba-ba-ba-bum. Yeah, I don't think I need a profiler to know that this shit is not great. Do-do-do-do-do-do. Int returns everything but the last element. It's the opposite of tail. Oh, okay. But where do you want me to use that though? Like, and I think init will be slow as fuck as well, huh? Like, I mean, it's nice that the function exists, but I doubt that it's basically equal to take length minus one, you know? Or, I mean, maybe there is some optimization. Ah, for trimming the backslash n. Okay, yeah, sure. But then it wouldn't work on the example that I copied. So yeah, whatever. But how do I make this faster? I think the solution would be to do what? I think it would be nice if I could iterate over decompressed or like recurse into decompress, and like when I know that the first element of decompressed isn't minus one, I can just skip it. Mm, and then I build back the list at the end, but I'm not sure. I'm not entirely sure how to do this. So I think the first like two cases are correct. So, but fixed disk, could I do something like here as well, like do these notes and this will be like current and rest. Let's pretend the rest doesn't exist. And so when this happens, we want to build back a list where it's current and these and rest, something like this. And then we do fix disk, like so. The problem is that I'm losing the... Oh, actually this makes sense. And then can I do fix, well, it's something else, like D, and this will just be, I guess we can do rest. And in this case, yes, that's what I meant with the character replacement logic. Fdisk, D, rest. Ah. Wait, and what do I do now? I'm not sure I need to decompose this. I don't think I need to. Like, whatever, let's call it X's for now. I just need to do D. Like this. Wait. Like this. Is that any good? Fuck, life is much better when you actually use Haskell. It's smaller, a billion times more efficient. It's more understandable as well to some extent. Fuck me. Anyhow, so yeah. Well, I mean, I don't know if it actually works on the input, but we'll see. So this. No. That's the right answer. Okay. Fuck. Yeah. Thinking in terms of like procedural languages when you're doing Haskell is not good. You know what? Maybe I'm gonna keep this. Maybe it will somewhat maybe serve me in the future. Okay. So this is not great. Do I even need this anymore? Like the take thing? Non-exhaustive pattern. $23. Oh yeah, what about when this is empty? Well, if you encounter fix disk with empty uh, anything, then we can just return an empty thing. This is not the correct answer. Alright, whatever. I'll look into that later. For now this works. For now this works. Okay. So let's just do part 2 or try. Upon completion, two things immediately become clear. First, the disk definitely has a lot more continuous free space, just like the Amphipod hoped. Second, the computer is running much more slowly. Maybe introducing all of that file system fragmentation was a bad idea. The eager Amphipod already has a new plan. Rather than move individual blocks, they'd like to try compacting the file on his disk by moving whole files instead. This time, attempt to move whole files to the leftmost span of free space block that could fit the file. Attempt to move each file exactly once in order of decreasing file ID number, starting with the file with the highest file ID number. If there is no span of free space to the left of the file that is large enough to fit the file does not move. Okay, the first example from above now proceeds differently. This and 99 can fit in there, but nothing will be able to fit there. Oh, so no. Okay, so first it scans here, then tries to find a place for 88. There is none. Looks at 77, tries to find a place for it, there is. Then looks at this, there is no space, this, there is no space. Oh, wait, this and this, there is no space. And so 4, 4, there is space, and then 3, 3, there is no space. And there's a 2 somewhere, what? Oh yeah, and the 2 finally moves to there. The process of updating the file system checksum is the same, okay. Start over now, compacting the Amphipod's hard drive using the new method. Instead, what is the resulting file system checksum? Okay. Let's go back to the example. How do I do this? So, I think I can just adapt my fixed disk function. If I'm not mistaken, especially this part. Or can I? I didn't even try part 2. Oh. Uh, well, again, with normal programming language, these kinds of things seems almost trivial, but it's like just a bunch of for loops. Hmm. So fix this, compress the rest. So when I hit this, I need to like do a take while or like count the number of times it occurs. Then I need to find a spot. Uh, I need to find a spot. Okay, maybe I cannot reuse this. Maybe I cannot reuse this. Hmm. Let's do. Let's copy all this. Let's rename it to fix disk 2, like so, and let's push this guy at the bottom. So. Hmm. Actually, maybe I can stay on this. I think this is also still correct, so, but let's move it up because it's not the case that is complicated. So if there is an element that is not -1, oh yeah, but I have to do this first, yeah. So if there is an element that is not -1, then we proceed to the next because it doesn't interest us. But if it is -1, I think this will be different. So if it is -1, we need to count, like do something like let length of take while equal. Wait, I need to answer a very important question. Can I do something like equal -1? No, okay. I need to put the parenthesis. What if I add a space? Oh, okay, a space works. Okay, so I can do this. And so here as well, very important question solved. Span, then length the first element. Yeah, indeed. But let me do it the dumb way first, because I don't want to get too confused. I'm sorry. Thank you for your suggestion, though. D. And so let empty count will be equal to 1 plus this, and the 1 plus is for the -1 that we pattern matched on. Ah, you're right, I will need the rest of these. Okay, I understand you. I understand. Let me first do it like just to wrap my head around it. Like, I don't know, file size, yeah, whatever, non-empty count is going to be equal to, well, the same thing actually, 1 plus length of take while equal current in rest, like so. So, and now we can do like kind of if empty count is greater or equal than non-empty count, we can kind of fill the thing, then something, oops, let's put my then here, my else here. So if I can fit it, what happens? If I can't fit it, I just replace all the minus ones by... Yeah, you're right about the span. So empties, rest, like so. And this is gonna be span like so. Forgot how span works. So if I have so if I do span equal 3, no, it needs to be like lower. So it's not what I want. What if I do equal to 1? Okay, and since my thing is this, yeah, okay, it makes sense. So span will work in my case. And so I have a bunch of empties with that I can prefix with this. And actually I can do like these, like so. Oops. So I don't have to do weird things. I can do this. Like so, and then the non-empties count, I guess it can stay like this. It's probably fine. Yeah. So now I would like to, I don't know, is there like a... Well, I guess maybe the span thing was not needed. Because now I can do replicate empty count current plus 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 plus. Oh yeah, I need the span to get the rest. Okay, fuck me. And now I lost it. Oh well. Empties. These. How do I call it? How did I even call it? Whatever else is equal to span these, and I do length length empties. You can compose first length with span, since only the empties length is what matters. First length. Oh, you mean the arrow thing? Okay, yeah. Like, I still don't know. Like, is this correct? No, it's control arrow. Is that what you mean? You don't use undo tree. I don't know what undo tree is. So Vim plugin undo tree. The undo history. Oh yeah. Yeah, I could, but you know. How often do you run into situations when you need this, you know? It's like I run into this like maybe once a week or something, you know? It's like, is it really worth it to install a whole? I mean, it's a cool project though, but I don't know. I feel like I'm fine. I'm fine with my current setup. Don't want to spend too much time on doing more customization. So replicate like this, and it will be this. Is that it? Oh no, it will be ours. So what can I call it? Like this prime. Okay, so I think that's fine enough. I use it once a week too. It's worth it to me. Oh, well, yeah. It's just that yeah, I already have plenty of plugins and special tools and so on. But yeah, I'll think about it if I start running into it more often. Replicate. And so if there isn't enough space, I just keep it. Like, oi, decompress at this, decompress. Is it something like this? I need to remove something in. I need to remove something in there as well. But this will end up being my. This will be next decompressed is going to be equal to whatever this is. Yeah. Replicate is only usable if empty count is equal to empty. No, if there isn't, I think that's what they show here. I think like, for example, here I have three empty spaces, but I have like two numbers. The two numbers still fit. Like as long as they fit, it's okay. So yeah. So I think it is greater or equal. Yeah. Oh, it's not empty count. It's like non-empty count. My bad. Yeah. For that you're right. Do-do-do-dum. And oh yeah, but then I need to fill it with the difference as well. Horror. This is turning to not be so much easy. So it will be replicate. This like the difference between them. They can fit, but I think this returns two numbers into three. Hmm. Yeah, I'm not sure. But next decompress is this. Fix disk 2. And so this will be like this. And now I need to do something on the other guys. But I still need to use this condition to get the other guy. So it will be next decompressed and next next whatever. What do I call it? I call it nothing. Next foo. I'm sorry. Okay, I'm sorry. Uh, and so now I need to return a tuple. This is the first element. Yeah, this isn't great, is it? Something like this and something like this. And so if it cannot be fitted, I'm sorry, okay, I'm sorry. I'll find good names after. Well, if it can't be fitted, I guess it just stays the same. No, 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 not at all. It will be drop non-empty count on foo. Yeah, we need to ignore that block and go to the next one, of course. Yeah, and here what do I do? So if it could not, if it was able to fit it, oh well, I just do the same thing actually. Huh. Yeah, no matter what happens, if I was able to fit it, oh no, because there is a next spot where it can be. What a nightmare. No, so yeah, if it could be fitted, we drop it. That makes sense because was already fitted. But if it could not be fitted, huh? Wait, no. Let me take back the example. So, for example, here we arrive at 7. Isn't there a way where we go back? Yeah, I'm not making myself clear. I'm sorry. So 9 could be fitted right away. 7 could be fitted right away. Then 6 could not be fitted. So it doesn't budge. Then 5 couldn't be fitted at all. Then 4 could be fitted. And the problem is that oh no, I go in the right direction, okay. So that's good. I will first encounter 9, then 7, then 4, then 2. Hmm. I think that could work, except... Yeah, I'm not sure. Yeah, let's try it though. Oops, sorry. And so what happens if it could not be fitted? I think I drop it regardless. Like so. So, yeah, actually I don't need the tuple. Second is the second file to be moved after 99. Second, 2 is the second file to be moved after 99. Yeah, that should be fine. Because I never go after the -1. If... Huh. I'm not sure. I'm not sure. One plus length is not good. That's not correct, but I think I kind of know why, because the take isn't good anymore. So let's do print shifted. And let's also print the original, print decompressed, to have a side-by-side comparison. So the 9, 9 got fitted correctly, the 1. Why is there a 1 there? Oh, wait, I'm accidentally ignoring the minus ones. I'm accidentally dropping some minus ones. So... Where am I dropping the minus 1? I have to not forget that this exists. Next decompressed. Line 37. Replicate. Oh! Wait, yeah, okay, this should be minus 1. Yeah, indeed. That makes sense. Except parenthesis, I assume. Does this make a tiny bit more sense? Not really, no. I'm still dropping the minus 1 there. How? Oh, because... oh, yeah, okay, okay. So the difference here is minus 1 somehow, but empty count is larger, so why would it be... Oh, no, it should be 1. Um... Can I do some... just to see what happens, like a random plus 1? Okay, somehow this kind of worked. Well, not really, because there is no 2 here, but at least I have an empty space here, then maybe I should copy-paste this so that we have it on stream as well. So this, right. In let empty count you're using these as a character was removed from. You're using these as the character was removed. Oh yes, indeed. You're perfectly right. I'm not speaking loud enough. That does this make sense? I think it does. And now, yeah, now it makes. Okay, I need to remove this person. Oh, look, the 2 is there. The 2 is there. Let's fucking go. So 0099 to. Oh, I have too many ones. What happened there? What happened there? Why do I have 5 of them? Fuck. 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 It almost worked until it didn't. But because you're dropping everything that doesn't match with... that doesn't match, we delete everything bigger than 2. But because you're dropping everything that doesn't match, we delete everything that's bigger than 2. I would like just... Just a dumb helper function. Et if I is equal to -1, then dot else show I. Well, not show, but like, is there like a int 2-digit? Int 2-digit. And this with I comes from nice. Oh yeah. Okay, let's call it X, whatever. Whatever. It comes from X's. And this will all be, well, this will be a string. And so can I just say, okay, this is slightly more readable. This is slightly more readable. So here somehow there is a bunch of ones that were there. So the 777 should have been shifted, but instead it was a bunch of ones. Huh. Because you're dropping everything that doesn't match, we delete everything bigger than 2. Where do I delete this? I also need to stop this. Okay. I mean, I will have to change it, but whatever. It makes slightly more sense. Hmm. Oh, because at some point this is like reaching the beginning. Fuck. You do drop non-empty count there in fixedx2 return whether the file was able to fill the spot or not. Yeah, I kind of want to do this because, like, if I tried to fit it in and it didn't work, I just want to keep it where it was. Or at least that's my reasoning. No? Because like the second list is only there so that I can iterate on the groups of stuff. Actually, I should just use groups. Ah well, whatever, another time. But um, yeah, I should just have a bunch of groups to iterate on. That would be much easier. Um, Non-empty count. Foo. So you don't want to do this. You do drop a non-empty count and fix dix to return whether the file was able to fill the spot or not. I feel like I kind of want to do this, but yeah. The drop there means that we are trying to fill the one block gap. Will throw away every file until we reach 2. And then we'll fit the next 3 block with ones. The drop there means that when we are trying to fill the one block gap, we'll throw away every file until we reach 2. And then we'll fit the next 3 block with ones. Yeah, I do understand that like it reaches this point and like the -1 is at this point. So it fills this with 1 and then it reaches 0, 0 and it fills the first spot there. I just don't understand why it's not able to go at 777 and fill this first. Because that shouldn't be too bad. Oh, so I should retry. Oh, okay. This means that if the first spot of -1s wasn't big enough, I'm not trying on the next spots for -1s. Okay, I understand. Okay, even if I fix this, I think I don't think it will work, but let's redo my disgusting thing. Where here this is just so if we do find a spot we want to drop. If we didn't find a spot, we do not want to drop. Is that it? I think it is. No. Because at some point... At some point what? It will get stuck. It will get stuck. Where do you get stuck now, my dude? This 2 should fill one empty spot and return the remaining filler cars. So when concat with them, the files we couldn't use. We concat the file we couldn't use. Fuck. I don't understand. I'm dumb. I feel dumb. I think my whole thing is kind of funky. I think this should be a group list, not my weird thing. Wait, why is it looping indefinitely? That should be the first thing. It's because here, at some point we have foo. How do we know? Ah yeah, how do we know that there is absolutely no spot for this guy? How do we know if there is absolutely no spot for this guy? Doo-doo-doo-doo. Next foo. I think that will be my first defeat in the advent of code. Even though I think I should be able to fix it. Uh, but yeah, I'm getting hungry. I'm getting quite hungry. Uh, but yeah, so but for future me, if he ever gets motivated, if you make it return decompressed as well as foo on every invocation, you'll be able to skip the files that are too big in reiteration. Then take the new foo value and concat it with the files you skipped. If you make it return decompressed as well as foo on every invocation, you'll be able to skip the files that are too big in an inner iteration. Yeah, I'm sorry, I'm just brain dead. But I'm sorry, I'm sorry. Thank you for trying to help me, but I'm like a mental asylum patient. I have heavy retardation right now. But my initial idea was make second argument groups with associated indices and make sure zero index isn't before its initial position. Anyway, I think that will be all for today. I can copy paste your why can't copy paste your stuff. Boom 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 boom. There you go. Your effort won't be completely vain. There you go. You'll have a trace. Oop. Boom 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 boom. Hop. See, that's what happens when the chat replay doesn't work. You put the chat replay in the source file. Isn't that great? Oops. Anyway, I think I'm gonna eat and yeah, just reminisce on my failure. Nah, I'm just gonna chill. And yeah, maybe I'll see you tomorrow. Hopefully I'm not full retard tomorrow. And yeah, see you. Enjoy the evening. And oops, should probably put that back. This guy goes back to the top. And this guy goes back to just being the regular checksum. Boom. There we go. Anyhow, see ya.